All right, IBAASL2. Today we're going to talk about closure notes. We've reached the end of chapter 7. It was a shorty but a goodie. Let's talk about what we learned there. We first started looking at scatter plots. So I showed you guys how to make scatter plots on your graphing calculator. So I'm going to add that. But we also, I could just give you a scatter diagram and ask you some things about it. One skill you should have is by talking about the correlation by eye. That means that you can look at it and talk about how clustered the points are around a linear or nonlinear trend. If they are linear, you should be able to tell whether it's going uphill, which is positive, or downhill, which is negative. We did briefly talk about nonlinear correlation, which can be strong or weak, but we didn't really show you guys how to find like a measure of it other than just looking at it and being like, yeah, it looks like a parabola or it looks like a exponential or something like that. But we did talk about strength. Remember, the more tightly clustered around a trend it is, the more correlation it has. Then we talked about this person, Pearson's correlation coefficient. Pearson's correlation coefficient is a lowercase r, and it's between -1 and +1. Remember, the closer it is to -1 or +1, the stronger it is. There was also a diagram, a chart that told you guys about the cutoffs for describing the strength of linear correlation. Oh yeah, that's a good point that we should put in here. Pearson's is only for linear correlation. Yeah, there was that whole cutoff about 0 to 0.25 is very weak, and 0.25 to 0.5 is weak, and 0.5 to 0.75 is moderate, and 0.75 to 1 is strong. I won't expect you guys to know those cutoffs, like if it's 0.72 or something like that. I'm not going to make you say it's moderate, but just know that the closer that gets to 1, the stronger it is, and the closer it gets to 0, the weaker it is. Then we talked about the line of best fit. We started out by talking about the by eye method, which is finding a line that goes through the mean point. The mean point, just to remember, is x bar, y bar. Your by eye lines of best fit should go through the mean point. They should get about half the points above and half the points below and kind of go with the trend of the data. Like if it looks like it's going a little bit uphill, your line should go uphill. Know how to find the equation of a line given 2 points. So goes through the mean point and then some other point. That's not a highlighter. You might need the slope equation, which is y2 minus y1 over x2 minus x1. Know how to interpolate, which is using your line of best fit to find a piece of data that's in between all the data points, or extrapolate, which is using your model to find a piece of data that's outside the data points. Least squares regression means finding that line of best fit on a calculator. I showed you guys, I posted videos about how to find it on a TA84, 83. It's mainly using your lin-reg. Remember that you can also find the Pearson's correlation coefficient from lin-reg as long as your diagnostics are turned on. Know how to interpret the slope and the y-intercept with a word problem. So if we're talking about, the number of shrimp that are being eaten per hour and the slope is -2/3, you can interpret what that means about the problem. That, for every 3 hours that go by, 2 more bins of shrimp are eaten or something like that. And the last thing we did was knowing how to find a line of best fit that's y on x, or sometimes it behooves you to find an x on y. Remember that the y on x means that this is a y equals something with x, and an x on y means x equals something with y. And that is it. Good luck with the review. Please ask me questions.